пожалуйста.
Good morning, dear colleagues. I'm very glad to welcome you on our first session. And it's both a pleasure and an honor for me to introduce our first speaker, who is Professor Ladjel Bellatreche. He's a full professor at National Engineering School for Mechanics and Aerotechnics of Aerospace Engineering Group in Poitiers, France. He also leads the data engineering group of the Laboratory of Computer Science and Automatic Control for Systems. He was director of the ISAE laboratory from 2011 till 2012. Besides, he spent some years as a visiting professor in different universities in Europe, in China, in Canada, and other countries. His educational activity is also very impressive. In particular, the number of PhD students supervised by Professor Ladjel Bellatreche is about 30. Besides that, he served and serves as a member and editor of different editorial boards of different journals. And also he was and he is a member and principal member of program committees of different conferences. He is an author or a co-author of more than 270 papers in international conferences and journals. He has received more than 3,000 citations, and his index is 27. So we will hear the talk called Towards Green Data Management Systems. And Professor Ladjel, you have 45 minutes. So please, microphone is yours.
Okay, thank you very much. Are you hearing me?
Yes.
Okay, good.
Yeah, sure.
Now we don't hear you.
Okay, now are you hearing me?
Yeah.
Sure.
Okay, thank you very much for this invitation. I would like to thank all the organizers that give me this invitation to give a talk about green data management system. I am not so lucky because I never visit Russia, and then I thought maybe I will visit Russia this time, but maybe it's next time to visit Russia. Okay. Let me give you the context of this work. I am doing this work, since 5 years with my my colleague and my students, and basically, as computer science is working in database, the culture in database, I mean, is mainly oriented to query performance. If you, for example, go in Google Scholar and just type, query performance in database, you'll find many papers, like, more than 20,000 entries. Why? Because in database, people, they were looking, to propose efficient algorithms, to speed up the query execution. If we take example of, for example, about join, there are many efforts about, how to optimize join. For example, hash join, sort merge join, partition join, and all these implementations. And then if you go, in 90s, you'll find, an amplification of physical design phase, where many research were focused in how to select, advanced optimization techniques like indexes, materialized views, compression, and all these techniques were mainly focused in query performance. And since we are living in the era of green computing, and even more in climate change, I think we have to focus our research as computer scientists about, how to change, the culture of query performance to another culture, which can be like, green or green driver research. And then why we are doing this, I think to prepare ourselves maybe to manage another, crisis. Because, for example, if you look in Europe, even in the world, there are many, people discussing about, smart buildings, smart car, even more, zero aircraft, there are many programs. And I think as computer scientists, and even more as database people, we have to think about how we can integrate, the energy in our research. And then if you go, for example, in AI, there are, if you take this life cycle about, the AI project, you can easily, identify 5 layers. For example, you have the source layers, network layer, data layer, exploitation layer, and reporting layer. And if we take this this nice picture, there are many research related to each layer, and the effort now is how to speed up, this this layer. For example, if I take example here, for example, about the data layer, all people are trying to propose, algorithms, to clean data, to curate data, to transform data, and even to process the data, and then to get some knowledge, and then to get some visualization. And I think we have to orient this research from, performance to green driven solutions. I think we have to inject and we have to integrate, the energy consumption or even energy efficiency in all these, steps. And how we can do this? The basic idea is how we can do this. As computer scientists, if we are like 30 people, we are working in database and present in this conference. How we can do this? I think we have to start, small. We cannot, start, with doing big stuff. Just start small. And then I would like to share with you this experience and how we can start small to do something. As data scientists with my research in my research group, the basic idea is that since we are expert in database, in data management, we are teaching database, we are using, open source system like Postgres SQL. Then how we can integrate the energy? I will show you this how we did this in my group. For example, here we have this this data, and then surprisingly, the data now becomes the most valuable resource in companies, in IT companies. And since the data is the new oil, then automatically it generates CO2. And then how we can deal with this data to generate less carbon. Okay. Then if we go in the landscape of DBMS, that if we go even over this website dbengine.com, we find more than 3,000 DBMS, and in large majority of these DBMS are open sources. And here, for example, we have here this ranking, and therefore we find this MySQL and the Postgres SQL in the top 5 of these DBMS. Then the advantage of this is that we have some open sources, the DBMS, then we can play with our students to maybe to change the performance culture and then replace it by green cultures. And if we can go more, if we go to the context of big data and machine learning technologies, we can find many open sources that we are using. And then since they are open source, then maybe we can play with them. We can have like open in frameworks, query, data flow, data access, the databases, streaming, security, visualization, research, all this stuff, since they are built with open sources communities, maybe we can go and then we can even ask our students, to change the initial philosophy. And then if we go in the data center, in any companies, even in our lab, we can find that the energy. I mean, you can find that the energy consumption of a data center, it's about IT, IT equipment, and then you have another part which concerns the cooling, facilities, and then all these things, generate, a lot of, money and CO2 and the carbon, effects. And then if we take a zoom, I mean, in this data center, the DBMS is the one of the major energy consumer. Why? Because the DBMS is in charge of, processing data, storing data, querying data, visualizing data. Even if you want to do machine learning stuff, then you have to use this, this DBMS. And then here in my group, and even I organize many specific issues and how we can build, some in an energy-aware DBMS. How we can integrate, the energy culture in DBMS, even when we teach the database to our students, to tell them that then, instead of choosing, the best query plane that optimize your queries, maybe you can use the plane that reduce the energy. Okay, and here I did like a survey about the energy efficiency techniques that can impact the energy consumption when you are using a DBMS. And we divide these techniques in two main parts or two main levels. The one level is system level, which include hardware and the firmware and software techniques, network techniques, cloud, and virtualization techniques. And here, if you take your computer, and then you are doing your database, then you have your machine, your CPU, all the hardware, the infrastructure that you are using. And here you have many solutions that you can use to reduce the energy when you are processing the queries. And then you have some software techniques. Then you have to provide models based in the data that you are managing, to predict the energy. It is like when you are predicting, the energy consumption of your house. The basic idea is that which kind of parameters or which kind of features of your DBMS that includes, the hardware, the software, the database, the tuples, the attributes, the queries, that the predicates, all, the ecosystem of your DBMS that impact, your energy consumption. And then if we get this, then we can provide some algorithms, to find, to guide us to find, the best query plane when we execute our queries. And then you have, some other level about, the environment that you are using. And the environment, it is like, the energy efficient resources that you are using. Are you using, like traditional energy sources, or you are using solar sources? You are using photovoltaic sources? Which kind of source that we can use for our, DBMS, to reduce, energy. And another aspect is about the cooling system. Which kind of cooling system that you are using, for energy, and even more, what are the user? How the administration or how the students use the computer when they are managing with the queries. If we, it is like, the ecosystem that manage your DBM, your energy when you are using, DBMS. And then here with my students, since it is like, timely subject, I ask my students to work together and with my colleagues, to find a roadmap for research. I mean, we submit this paper. We are waiting for results for TKDE journal, and then we put a roadmap, to see how we can deal with energy consumption in database, because there are many directions. Because we have, as I told you before, you have some part about hardware, you have some aspect about software, you have some part about for example here we have we have to develop cost models to predict to quantify the energies. Then you have some aspect about the modeling, how we can model the query when you execute when you execute the query in your system, how the pipeline of your queries is managed, and how we can integrate this knowledge to provide cost model. You have some aspect about machine learning techniques to do regression stuff, because we have, since we don't have all parameters to predict the energy, then we have to do training of your system based in some queries to get some parameters that may impact your energy consumptions. And then you have information about, for example, the buffer management, because the buffer management impact the energy. You have information about the type of your database. Is your database parallel or centralized or distributed? Then you have other direction about the device that you are using. Are you using CPU, GPU? Are you using both of them to process to speed up the queries? And then this roadmap, I think it is very good for a new researcher to start thinking which is the best direction to do research in energy in database. Okay, here I will give you my agenda, and then I would like to convince you to maybe to think or to work in energy consumption in the future, and how we start. I will share with you my experience, how we start dealing with this problem, and then what are the feature selection that impact our energy model. And then we try to model energy in DBMS, and then I present you a validation that we did in 2 DBMS. One is PostgreSQL, which is row stored system, and we use another system which is MoneyDB, which is a column store system. And then I give you a summary. Okay. Then if you start thinking about the energy for any object, house, car, DBMS, any object if you have in your life, I think you have to do some audit. We have to know how your system works, because we cannot, for example, you cannot predict the energy in my office. If you don't know what is the square meter of this office, you don't know how many windows I have, you don't know how I behave in my office, you don't know the number of lights in my office, then you have to come and see my office, and then the behavior, how I behave in my office. And then in database, when I start working in 5 years ago with my students, and I ask them, okay, if you want to do this work with me, you have to understand, how the world of query processing work in database. Because, the query processing, it is the major, consumer of energy. Why? Because it manage a huge amount of data and then process them. Then, it has many effort to provide, some solution to the end of users. And then if you take, the basic, architecture of query processor that we teach to students, then you have like queries, you have applications, and then when you write your queries, your query has to be compiled, and then we have to optimize, these queries. If you are using index or other techniques, and then when everything is optimized, when you get your query plane, then you go to a storage manager, and then you get all the information. You get your data, and then maybe you can get the index, and then you process the queries, and then you have many possibilities. Even the storage manager, even you have data in your disk, or you have data in your main memory, like like HIRES, for example. The HIRES system was developed by German people, and even we are working in this system actually in our lab, to see the query energy consumption about queries when you are dealing with main memory database system. Okay, and then if we go inside, then you can see easily that you have your server, you have application, you send SQL via network, and then you have your query processor, and then your data manager, and then data storage, and then from you send SQL, and then you get blocks, and then blocks you get page, and page you get tuples, because you are going to your disk. In the disk you have blocks, and then you send page, and then page you send tuples, and then you send the result to your system. And then here the basic idea, if we want to see which kind of component which are energy aware, then we can find all these components can impact energy. Okay, very good. Then since here we are the unit of our work, it is queries, and here I will show you example of this kind of queries. If, for example, if we get complex queries like OLAP queries, then you have in OLAP queries you have this start schema schema, and here we have an example of start schema benchmark with this fact table and the demotion tables. And then if you have these complex queries, and then in your queries you have like joins, you have many joins, you have selections, and you have like aggregation, and then you have some you can even have some order by statement. Then if you analyze this, because since we are doing audit, if you analyze this, you can easily identify that this queries has many joins, and each join operation passes through the fact table, and then this operation is very costly. And then you have the presence of selections in demotion tables and aggregation. Then we know this. And then if you do query processing, I think we have to know how our system works, how your DBMS works to do query processing. And then the first issue is about the variety of query trees. Then you have many query planes that we can generate, because we have these properties about relation algebra, and then we can generate many planes. For example, here I can put here the selection, and then I can put it here or here or here. Then you can generate thousands of query planes, because you have a variety of plane. And then from query tree, then we can discuss about query plane. What does it mean query plane? Well, it is the implementation of each operation in your system. How we implement selection, how we implement join. In terms of algorithmic point of view. For example, if we do selection, when we teach the students in the first class course selection, then we said it is like a filter. But when we go, in the second class course, then we say, okay, selection, how we implement the selection. We can have index, we can have, full scan. And even for the join, we have many implementations, and each implementation has its cost, and the cost, it may impact the energy, or the algorithm may impact the energy, and then how we can choose the best algorithms. It is the cost-based approach that we have in any DBMS actually. I mean, to identify the best one, we have to build cost model, and then the cost model will tell us this implemented is better than this one. Okay. Okay, and then here you have an example of this query plane. We have, for example, here we have selection, and here I said, okay, I use index, here I use hash join, here I use sort merge join, and here I use full scan. And then why people do this? Because, we are in performance culture, query performance culture. What is this? It demands speedy access to data no matter how the complex query are. All people, all companies, Alibaba, Amazon, they ask for query performance. They don't care about the other aspect. Okay, that's why to select the best query plane. The problem is NP hard, and there are many algorithms that have been proposed based in dynamic programming, greedy, heuristic, and for example, like in Postgres, we can find genetic algorithm to find the best plane. Okay. Okay, now how we can estimate this the query cost? How we estimate the query cost? It is related to a no functional requirement. For example, query performance, energy consumption, price. How we can do this? People working in query performance or query cost model. Sorry, cost model is that they focus in one elementary operation, and then for each elementary operation they build a cost model that estimate the cost for this one using some parameters like, for example, input output, CPU, network transfer cost. And then here we have this operation and its implementation, and here we have the metric that we can use CPU, IOs, as I said, and network. And then to build this cost model, then you need some parameters. For example, you need parameters from the DBMS, from the hardware. You need parameters from the database with the tables, attributes that you have, and then you need some parameters from the queries. How many join you have? What are the selected factors of your database of your queries? And then you have other parameters from the platform. Which kind of platform that you are using? I mean, are you using centralized platform, a distributed platform? And then you have parameters about the hardware, which kind of hardware that you are using, and what is the age, for example, of the hardware. And then for each operation, then you get the values. The cost model, take the operation and its implementation and some parameters, and then it give you an estimation how it costs about the criteria that you are using. I will give you example here. If I give you example to just to understand, for example, the number of IO of these queries, select star from table T, and then here the function of your query optimizer is that the CPU can work in tuples and they are in main memory. The tuples must first be transferred from the disk to the main memory. Then you have the data stored in the disk. Disk is divided in blocks, and each block contain tuples. Then you have to explicit, all the information that you have to understand. I ask students, to give me models to understand, the whole picture of your DBMS to understand. Otherwise, we cannot give good prediction. And then we have this. And then if I want to know what is the cost in terms of IOs of these queries, it is the formula. It is the number of instance of my table times the length of each instance divided by block size. And if you take here the block size, it is a property from the systems. It is not property from the database, because it is like Oracle block size or Postgres block size. And then you have other parameters from the tables here, and then you have other parameters from the queries. This give you just an example how we can build cost model, and then we can take example of a complex cost model. Okay, and here we have this architecture about query optimizer. Then when you write your query, then your query has to be parsed, rewritten, and then we generate the trees, and then we can have many query. I mean, the tree can be transformed in planes, and then we have many query planes, and then we have a cost model, and then we have a research strategy based in statistics, and then we can get the information. Okay, why we need the statistics? Because here, you know, we have a number of instances. Usually, it is statistic. It is not the real one, because we have to decide when we execute the queries. That's why we need this statistic to get the information. And then based on this query plane, then we can elaborate, you know, a strategy to get the best query plane that optimize your plane in terms of I/O, CPU, or pricing, you know, energy consumption. It is the basic idea. Okay, and then you have here you know your stuff. Okay, now it's about energy. Here we understand, you know, the whole picture about, you know, the DBMS, and then energy. We have to understand what is energy. In energy, we distinct about, you know, power and energy, and you have this formula, you know, to estimate or to compute, you know, the energy consumed by your task or by your queries, you know. And then in energy, when you are working in energy, you have, you know, baseline power and active power and peak powers. And in our work, we are considering only the average power, because we are not using, of course, you know, the peak power, because, you know, I mean, it is not the reality, because in reality you have, you know, some moderate, you know, behavior of the energy. Okay, you know, and then energy features. What are the big questions is, like, you know, when you are doing machine learning project, the basic or the complex task is how you identify, you know, the features that impact the energy. And here you have, you know, in many recent work, many papers were focused in operating system and firmware to provide energy. In our work, we said it is not enough. I mean, we cannot, you know, buy, you know, the best, you know, CPU or we best main memory in terms of energy, and then we optimize energy. Because, you know, if you take a look in the slide that I presented before, you can identify that you have many aspects related to software, related to algorithms, related to cost models. And then we have, you know, we can take, you know, parameters from hardwares. We can, like CPU, about, you know, dynamic voltage when you are, you know, when you are transferring data from the disk to the main memory. You have to take into account, you know, if you are using multi-core or more one core, GPU, main memory, you know, all information about the hardware. And another stuff is about, you know, the network. If you are using the network, which kind of the network you are using, and, you know, you have to consider, you know, information about, you know, the cooling system, temperature control, and the good practice. And all this stuff you have to consider, you know, the software. Software, it is here, and then he manage all these parameters. And then our vision is to combine, to propose a joint solution that combines, you know, software and hardware solutions. And then here I ask my students, you know, to give me, like, you know, like a diagram to identify the different parameters that I have in the DBMS ecosystems. And then if you take, you know, the DBMS ecosystem, you find me a parameter from database, from the queries, hardware, and architecture. And for each level, we can do some zooming, and then we get all information. For example, in database, you can have the storage types, relational, no relational, data management parts. If you, what is the size of my buffer? What is the page of buffer management of the schema? I am using row-oriented storage or column-oriented storage. You know, for example, if I take example about, you know, the queries, you know, what are the operations that you are using? Are you using join, aggregation, scan? You know, all the information that you have in your DBMS. You know, for example, you know, the hardware, I'm using, you know, CPU, GPU, FPGA, and all this information. You know, and then if I get this, I can, you know, propose a cost model to tune my system to get the best information. And then how I can build, you know, green query optimizer? I think we have to reuse the effort that has been deployed in query performance. All this effort in query performance were based in cost model. Then we have to think how we can propose cost model, mathematical cost model to estimate energy. And then what we need, we need the relevant parameters that impact the energy. We need, as I show you, an audit how query processing works. And then if tomorrow we want to do it in transaction processing, then we have to do the same audit in transaction processing. And then we have to propose machine learning techniques, to get the best values of these parameters, because as a parameter, we don't have the real values. Then we have to use, some prediction. And then you have to deploy the system in your algorithm in some open source system to show the results. And here it is example, about the cost model. The cost model here is like, you can build your cost model based in these query trees. And then it's okay. Here, when I have the cell, then I need 3 watts to get the table cell from the disk to main memory. And then I have to do like pipeline. And then if I do selection, and then I have 3 watts that I got before plus the cost of the selection. And then I have to accumulate, all this cost to get the final cost. Then if I estimate this cost, then I can easily build a nice cost model for energy consumption. It is the basic idea. Okay. And here we have another point. We spent like 5 months, and we spent 5 months, but we didn't get a nice result because we didn't take into account the pipeline. Because my students in the beginning, when we were developing cost model, we thought that we forget the pipeline. And then because when you are doing database, the system work in pipeline. You have one pipeline, and then you get some result, and then you send the result. Then you take the second pipeline, and then you get some result, and then you go to other steps to get to get the final result solution. And here we can see that query execution go from one pipeline to another pipeline. Energy consumption change. Because you change the environment, and the pipeline has impacts seriously the energy consumption, because it is not like sequential. I do the selection, I get the result, and I send it to the join. No, you do selection, you get some result, then you send it to the join, you do the join, and then you are doing things in pipeline mode. And then that's why you have to understand the whole picture of the systems. And then based in this, we developed energy models, and then we said, okay, intuitively, how we can quantify the energy, how we can quantify the power.
Ladjel, 2 minutes left.
Okay, since we are working in only centralized system, then we have CPU and IO, and then we developed. We said, okay, the power it is like a parameter multiplied by CPU cost, and another parameter multiplied by IO cost. And then we developed machine learning algorithms, to get all these parameters, and then we deploy these parameters in Postgres. We take our Postgres, and we divide it in 2 parts, offline part and online part. And then the offline part, then we have this machine learning stuff to get all parameters, and then we change the cost model about query performance by cost model about energy consumption. And then we get, we have here, I can show you, we have this, I would like to show you maybe this. We have this, we have a demo about, are you seeing by the demo or not? No. Okay. We have the demo, I can send you the link. And then we present the demo in CAKM in 2016. And then we have, we can use, this, our demo. Maybe I will show you the demo when I finish the presentation, okay? Oops. Okay. And then here, now to conclude, the summary is like, I try to convince you that, it is good, to integrate, the green label in your research. Whatever research that you are doing, even query processing, transaction processing, machine learning stuff, then you have to think about the integration of energy consumption. And then I try to share with you a generic methodology to integrate, the green aspect with the motion in your research. Then to do this, you have to understand deeply, your study domain. It is very important. And then I'll give you in implementation or in instantiation of this vision in query processing. And then I show you how the benefit to combine hardware and software solutions. And actually we are working, in considering, multi-core processing in query energy. And then even more how to integrate, since you have Oscar Pastor, the second keynote, how we can integrate, the energy consumption in conceptual design phase. And here we have this production that we get from this work. And I would like to thank to my colleague that participate in this project. And thank you for your listening. And if you have question, please don't hesitate, please.
Yes, thank you very much, Ladjel. Questions, please.
Okay, Ladjel, may I have a question?
Sure.
Okay, actually, concerning first, thanks for the very interesting talk. And my question is that actually the essential part of your work is a relational data model.
Yes.
And what do you think about the perspective to expand all the methodology, all the approach for other data models like graph data model or RDF or something else?
Sure, very nice question. Actually, because since I speak a lot, my initial presentation that I can send you the slide. I consider two systems. MongoDB system and Postgres system. I think the methodology, and here this year I have a new PhD student working in Sparkle query optimization. I think the methodology it is similar because that's why I said that I propose generic methodology, and I think this methodology can be deployed for any kind of database because I associate this methodology in relational database. I think you have to do the same effort if you want to make green your RDF DBMS or your I don't know, or your XML database or your object-oriented database. I think it is still the same because the methodology it is like it is the plane of my presentation. You have to do audit, feature selection, energy modeling, and then you have to validate.
Okay, thank you.
Thank you, Ladjel. Any other question? Well, I would use my privilege to pose a question. Your ideas and suggestions are extremely interesting and important, I think. However, I think that these efforts should be international. You, Ladjel, you have a large experience in international collaboration. So could you please tell us a few words about advisability or involvement of international scientific community in this activity?
Yeah. I mean, here, very nice question. I got, based in this work, I got very nice, European project this year, about circular economy. There are many people working, for example, in database, working in machine learning stuff to do smart building, for example. But they store the data in some DBMS which is not green. I think we have to convince people that the green stuff has to be in the whole chain of data. I mean, you get the data from your car or from your building, and then to make your building green, but the data that you store and your process has to be green in your DBMS, and then the DBMS has to be green. And then I sent another project this year with Estonia, about this circular economy. I mean, everything has to be green. And I think it is very nice, direction to do research. And even in this work, as you see, I have this one guy from the US, and now I have people from the Estonia, and I think we can federate, the effort in terms of organizing, special issues about in conference or even special session, to promote this aspect. For another aspect which is very important is about teaching. For example, in my class, I am using this Postgres because you can download the system here. I will show you just here, please. Yeah, you can download the system here, and then you can take it, and then you can use Postgres Green. And I show to my students, instead of using Postgres that optimize queries, you are using Postgres that optimize energy. Just to promote the idea in our research, to make green. And I think another aspect, I think in the future, we will have many courses about project in green computing. I think we have to be, to be prepared, to respond to this kind of project.
Okay, thank you, Ladjel. Any other question? Doesn't seem to be the case. So let's thank Ladjel again. And please unshare your screen. And I guess that according to our schedule, now we have some kind of virtual coffee break. So I pass the microphone to the organizers. Thank you.
Thank you very much.
Ladjel, one remark. Could you please send us these your slides? Is it?
Sure, I will do.
Okay, thank you a lot.
Sure. Send me an email. Please send me an email. I will send it to you, the slides.
Sure.
You can put my slides in, you can put this in the webpage of the conference. It's okay for me.
Yeah. Thanks a lot.
Yeah, send me an email, please.
Okay.
Sure.
Bye.
Okay. Thank you, Ladjel.
Thank you.
Now we have a coffee break for 10 minutes, and the next session entitled Data Integration, Conceptual Models and Ontologies will start at 12 p.m.
Okay.